Let's try a proof together that deals with some triangles. To begin, let's look at the given information that we have. As usual with these two column proofs, let's go ahead and look at what we're given first. Alright, for starters, we know that E is the midpoint of segment AD. So that means when we look at segment AD, E is going to be directly in the middle, which creates two congruent segments of AE and DE. And we also know that E is the midpoint of segment BC, so that lets us know that this segment of BE and EC are going to be congruent to each other as well. Now, with that given information, let's see if we can prove that triangle AEB, which is this triangle right over here, is congruent to this triangle DEC, which is this triangle over here. Let's go ahead and write a two-column proof now. Alright, for our first statement, let's go ahead and say that E is the midpoint of segment AD and the midpoint of segment BC. And of course, that is just given. Now for statement 2, let's see if we can say something else based on that information that we were given, like saying that segment AE is congruent to segment ED. And we can just go ahead and say this by definition of midpoints, since if E is the midpoint of AD, then AE must be congruent to ED because it's directly in the middle. And very similarly for statement 3, since we know that E is the midpoint of segment BC, we can say that segment BE is congruent to segment EC. And this is also by the definition of a midpoint. So at this point, we used the information that E was the midpoint of both of the segments AD and BC, and that helped us figure out that these line segments are going to be congruent to each other. So the segment AE is congruent to the segment ED, so we know that when we're looking at these two triangles of triangle AEB and triangle DEC, they do have a side that is congruent to each other. On top of that, we've also identified that segment BE is congruent to segment EC, so we know that these two triangles of triangle AEB and triangle DEC have another side length that are congruent to each other. So if we're trying to prove that these two triangles are congruent to each other, we already have two sides that we know are congruent. What else do we need to maybe go ahead and prove that? If we could somehow prove that segment AB was congruent to segment CD, then we could use side, side, side. But I don't think there's any way we can go ahead and prove that. However, something I think that we can prove is the fact that this angle over here of angle AEB is congruent to this angle of CED. If we can go ahead and prove that those two angles are congruent to each other, then we can use side angle side to prove that these two triangles are congruent. We know that this segment of AD is a straight line and also BC is another straight line. So if these two straight lines are intersecting each other, they must create these vertical angles here. So for statement 4, let's say that angle AEB, which is this angle here, is congruent to angle CED by the vertical angles theorem. And so, looking at these two triangles of triangle AEB and triangle DEC, it looks like they have an angle that is going to be congruent to each other. Now here is a side that they have congruent to each other. Here we have an angle that we have congruent to each other, right, sandwiched in the middle between the two sides. And then we have another side that is congruent to each other. Notice how we have this side and then we have the angle sandwiched between the two sides here. So the angle's in between the two of them. So this is side, angle, side. And notice that it is the same for this one over here. So we have this side, and then we have the angle, and then we have this other side opening up over here. At this point, we are ready for our final statement for statement number 5. And we can say that triangle AEB is congruent to triangle CED. And we can say this by proof of the side angle side theorem. And so we know that triangle AEB is congruent to triangle DEC. Alright, so that just about wraps up this proof. So we were initially given that E was the midpoint of segment AD, but it was also the midpoint of segment BC. We went ahead and used our side angle side theorem and we proved that triangle AEB must be congruent to triangle DEC. If you found the video helpful, please consider giving it a thumbs up and letting me know in the comment section down below. And as always, keep with the great work that you're already doing, and I'll see you in the next one.